Hi, everyone. Thank you for joining us for ID.me, Climate Resilient Trees. This session will go about 15 minutes. My name is Tanner Stoffren. I am the I'm the Marketing and Communications Coordinator for Wild Rivers Conservancy. I work closely with the Climate Resiliency Specialist, Alexis. I will be in the background moderating our discussion today and help you with chat and any technical difficulties. Before we begin, a couple notes. If you do have questions throughout the presentation, please use the chat in the right side of your screen to type those out, and we will have time at the end for Alexis to address those. This session is being recorded and will be posted on our YouTube channel for those to watch and share after this week. With that out of the way, I'd like to introduce our speaker today, Alexis Monti. She is our Climate Resiliency Specialist at Wild Rivers Conservancy.
Lovely. Thank you, Tanner. I'll get my screen going. Well, I'll get my screen shared and we can get started. But yes, hi, everyone. Alexis Monti here, Wild Rivers Conservancy. For my job, I work a lot with trees and climate change. This is kind of a wonderful presentation to be giving for me. I'm super excited to talk to you all about trees because I find them super interesting, and I'm hoping by the end of this presentation you guys do too if you don't already. So I just pulled my presentation up, so hopefully that looks good. Tanner, say something if it doesn't, but otherwise I'm going to get started. Super excited. So welcome to my presentation. It's ID.me, Climate Resilient Trees. I'm going to be using this to talk a little bit about climate change in the region and then also talk about how that's going to impact our tree species in the area. Climate change is going to impact everything and everyone. So even though I'm talking about trees, please know this is going to impact, the little shrubs, the soils, the people, the environment as a whole. It's going to impact everything, but in different ways. So some trees are going to do really well and some are not. And so we're going to dip into that a little bit during this presentation. But let's get into it. But before we go too far, I would love if you in your classrooms or students and whatnot thought about what your favorite tree is. When I say tree, what do you think of? Do you think of pine trees, maple trees, oak trees? What is your favorite tree? And then once you figure that out, or pick one, just keep an eye out for it during this presentation, right? Because I'm going to be talking about trees that are already here in our landscape, trees that we should ideally already know or will get to know. So just think about what your favorite tree is. Feel free to throw it in the chat if you'd like. I'm going to ask you again at the end to see if anything changes maybe, but each tree has its own personality, so it's okay to have a favorite. I know it's hard, but they are really fun. So now that we're thinking about trees, let's also think about climate. So climate in the region, you've probably seen this in earlier presentations, but I'm just going to give a really brief rundown of what it's going to look like in this Minnesota, Wisconsin area. But as we've established, climate change is going to cause warming temperatures. I do want to say it's not going to be warming consistently during all the seasons or during all times of day, right? It's going to get warmer in the winter and overnight, more warm than it does in the summer. So I find that really interesting with climate, that it impacts different seasons and different times of day more than it does other seasons, right? So that's part of why maybe our winters are going to feel so much warmer than maybe our summers do when you're thinking about the changes, right? So we're going to have warming temperatures. We're going to have extreme precipitation swings that could be droughts and floods. A lot of people think, oh, it's going to get wetter, so we're going to have more floods, but it also means we could have more droughts. It just might be longer periods in between, right? So longer droughts, longer floods, just more extreme when precipitation does happen. So it's going to be interesting to see with our so many rivers and lakes and stuff. That'll be interesting to see how that plays out with such a water-heavy region. We're going to be experiencing more wildfires and reduced air quality, most likely. We saw this last year with the Canadian wildfires that made it really hard to breathe for those couple of weeks during the summer. Those are more likely to occur. It's not saying that that's going to happen every year or anything like that, but with those longer periods of droughts or more severe droughts, that might make it more likely to have wildfires. And if that happens in the US, then the air quality could impact your regions even when there's not a fire actively present in our area. So that's something that might happen more often depending on how we manage our forests, right? And we're going to experience a longer growing season. So this is going to expand by almost double, right? So the plants right now have a designated amount of time where it's warm enough and sunny enough for them to grow. With the warming temperatures, that's going to make it so plants have even longer to grow. So we might have bigger plants or more hardy plants. It depends on the plant and the growing season. So we're going to have increased invasive species pressure, which I'll talk a little bit more about in a minute. We're going to have longer allergy and tick season. The allergy season kind of plays into the growing season. If we have longer time for plants to grow, that gives them more amount of time to flower, which gives them more time for pollen, which makes us have allergies if you're one of the unlucky people like me who has pollen allergies. Ticks also gives them a longer time to just wake up and stay active during the season. So we'll see more of those earlier in the year and later into the year as well. And much, much more. One thing I always want to stress about climate change is it impacts everything, right? It's somehow connected to everything we do, our industries, our lives, the nature around us. So I just want to iterate that, yeah, it's all connected. So, and then I just want to talk about this really cute little map for a minute, but I hope you guys can see my cursor, but if not, I'm pointing at Minneapolis right now. And there's this awesome map the University of Maryland made where essentially they're saying by 2080, so by the time most of us in this call are, I don't know, 60s, 70s, 80s, when we're those ages, right? I think so, yeah. When we're those ages, essentially what this map is saying is modern day Minnesota might look like Missouri or Kansas. So I don't know if any of you have ever been to Missouri or Kansas, but that's what Minnesota could look like in 60 or so years if we don't take any action on climate change. So that's part of why it's so important that we take action on climate change now, is because we could alter that so we don't look so heavily like these other more southern states, right? So just
Alexis,
a cool map. Oh, yeah.
Sorry to interrupt, but the PowerPoint got stuck and it doesn't appear to be advancing.
Oh, well, thank you for interrupting. Let's see what I can do to fix that. I'll just stop sharing my screen and reshare, and then hopefully it gets going.
Sure.
Oh, I see what you mean. Okay. Thank you, Tanner. Let's see, screen, share, window, screen. There we go. How's it looking now? There we go. Oh, I think I see what it's doing. Okay, I'm going to change my sharing settings and we'll see if that makes it a little better. Tanner, keep your voice on so you can just confirm while I get this working. Entire screen. Share. Here we go. Okay.
Seeing the climate in the region poster.
Good. Okay. So you guys didn't see it change at all during but you heard me speak, right?
Yep, all good.
Okay. So since you heard me, I'm not going to redo all of this essentially. Thank you so much, Tanner, for telling me. That would have been tragic for the rest of the presentation. But essentially, I just finished off with this map, which you just saw all those changes, right, Tanner? I'd say so. Okay, so this is where I left off. Don't worry, there's a bunch more of this presentation left, so we got it covered for the rest of it. But yeah, I was mentioning all the different things that climate change is going to do in the region. So we're going to have warming temperatures, precipitation swings, wildfires, longer growing season, increased invasive species pressure, allergy and tick season, right? And then we've got this cool map showing what Minnesota might look like in 60 or so years, right? Saying we might look like Missouri and Kansas if we don't take any changes on climate change, right? So that's kind of a quick summary of what I was just talking about. The next slide talks a bit more about increased invasive species pressure. So here we've got pictures of garlic mustard right here on the left, spotted lanternfly, emerald ash borer, and buckthorn. So these are all very common invasive species that have come from all over the world and are now in Minnesota and Wisconsin. And because of climate change, it's becoming easier and easier for these species to live in the region, which isn't necessarily a bad thing in all these cases, but it definitely makes it harder for our native species to survive now that they have other species to compete against, right? So, and like I said earlier, it is all connected. So climate change is going to impact the plants that live here, the say farming communities that rely on nature especially to grow. We've got different diseases, longer allergy season, tourism might change, like when people come. If it's really hot in the summer, people might try to come in the spring and fall instead of in the heat of summer, so it'll change that. It might change where people live, right? If it's really hot in the southern states, people might move to Minnesota to escape that sea level rise and extreme heat. So everything is connected when it comes to climate change, that's for sure. So now that we're all on the same page with climate, let's talk about what makes us hopeful, like what kind of actions can we take, right? So I'm just going to go very briefly into what people are doing with those big agencies we've heard of, right? So National Park Service, Minnesota Department of Natural Resources, U.S. Forest Service, right? Like this is what they're doing with our forests. So we, as the public, are protected and ready for climate change, right? So when it comes to forestry, there's three main options people have taken. There's resistance, resilience, and transition. And you don't necessarily need to remember all of this, but essentially the three main ideas, right, is you can take a forest and you can take the resistance approach and you're trying to use your money and your resources to put a little bubble around the forest, right? You just want to protect it from climate change and keep it the same as it's always been, or I shouldn't say the same as it always been, but the same as it currently is. You want to just preserve what you've got and you don't want it to change as the climate changes. And so that's resistance. Then there's resilience, which is like the middle ground, right? So you manage the forest as you can, but you allow for some changes to happen. And then there's transition, which is just climate change is going to happen. We're just going to change the forest now so it's ready for the future, right? So I'll go into that a little more, but like these are the options that the people in those big agencies that we've heard of are actively doing on our landscapes today. So this is just a little sneak peek, right? But yeah, with resistance, you take something you know and love, say the St. Croix River, and you take the trees that are protected around it, and you put your time, your money, and your resources into protecting it so it stays roughly the same, right? But over time, as the climate gets progressively more different, this is going to become harder and harder to do, right? Eventually, it doesn't really work out for the most part. But for now, you could use that to kind of protect your resources and keep it as similar as possible to what you know and love. So resilience is a little different. I'm using a prairie as an example here, but resilience is essentially when people go and they manage, say, the forest or the prairie in this example, where they allow change to happen and they try to make it stronger. So you're trying to promote the ability to rebound. So you take a prairie, which is a fire-dependent system, and you light prescribed fire. So you light it on fire, and then in a couple of years it comes back and it's this big, beautiful, flowery prairie, right? And if you do that over a couple of years, the prairie gets stronger and stronger. And then that way, when a wildfire comes through, the prairie is already super strong and it can handle the wildfire and it'll bounce back even stronger, right? So resilience is kind of sort of keeping it the same, but just doing things so it gets strong enough to handle the challenges climate change throws at it, right? And then there's transition, right? So I'm going to talk about this example a little more later on in the presentation, but here we've got these ash trees, and there's this little bug that's in Minnesota, Wisconsin now called emerald ash borer. Perhaps you've heard of it, maybe you haven't. Hopefully you haven't seen it. I hope none of us have seen this, but maybe some of us have. And so in this scenario, this bug is essentially killing all of our ash trees, which is really sad because we have a lot of ash trees and they're really cool trees, right? And so in the transition approach, a lot of people in those big agencies are trying to think about what happens when these ash trees die if they're infected by this beetle. And so what you could do is you cut down all of the ash trees that aren't going to live much longer anyways, and you plant oak trees, which are going to do really well with climate change. So these are kind of like the three main approaches people are taking to make sure that we have trees and healthy ecosystems into the future, even with climate. So just want you to know we are taking action because I know climate change can cause a lot of anxiety, and we don't always have to feel as anxious because we are trying to make a change. So, and there's a little emerald ash borer. So, These are other things people are doing. So if you've got a yard, maybe you have a big yard at home, right? And your family has a couple of trees you really love, like a big maple tree in the front yard and maybe an oak tree, right? Well, there's a couple things you could do on your own yard, at your own house, right? To make sure you're prepared for climate change. And so this is an option where people use diversity to improve resilience. So there's this phrase people like to use. It's called "don't put all of your eggs in one basket," right? And so I'll explain that a little bit more, but in our forests, we have all these different species, right? We've got elms and conifers and maples and oaks and ashes and all these awesome things, right? And when it comes to climate change, there's going to be trees that do better and some that do worse, right? Some are just going to love the heat, and that's totally fine. We love that. So there's these climate change winners and losers, but science doesn't know which ones are going to win and which ones are going to lose in terms of climate change. And so the best way to prepare yourself is to plant a bunch of different things, right? So you want to have all these different species, so that way when, say, two of them don't do well with climate change, you still have others that are alive and thriving, right? So this is another thing people are doing. And how are they doing that? Well, they're looking at all these awesome resources to identify the best native trees to plant. So we've got this awesome resource called Climate Change Atlas, which I don't expect any of you to use, but I just want you to know that these resources exist and that people are looking into what trees are going to thrive, right? So we have all this science that's backing our decisions and preparing us for our future conditions. So let's dip into this a little bit. Let's talk about climate champions. So these are the trees, this is the ID part, right, that are going to do really well with climate change. These are the trees we're going to grow up with, and they'll be on our landscape for the next, 60, 70, 80, 100 years, something like that, right? So these are the ones that are going to thrive. So what I'm going to do here is I have the name kind of blurred, but I kind of want you guys to look at these awesome photos and see if you can kind of identify the tree. You don't necessarily have to put it in the chat, but while you're sitting there in your classroom, think about, do I know this tree? Have I seen this tree? Is this in my yard? Have I climbed this tree, right? Like, think about if you've seen them before, because they're already here and they're here to stay, most likely. So I'll talk a little bit about its characteristics and then reveal the name in a little bit, and then teach you some fun facts. So that's how this section is going to work. But basically, this tree is very well known for its fringed acorn cap right here. Again, I don't know if you see my cursor, but I'm pointing at the top left photo, right? It's got that very fringed acorn cap, which is characteristic to only this tree. It's got these buds, which is another great way to identify a tree, especially in the spring when it doesn't have leaves. It has very characteristic oaky kind of oak leaves, right? So it's got these, I don't even know how fully to describe it, but these smooth edges in a funny shape. When you look at leaves, there's only one tree with this shape, really. And then it's got these deep furrows in the bark. So based on all of that, hopefully you came to the conclusion that this is a bur oak. This is one of the best trees, in my opinion, in our landscape. So I hope you guys all love it by the end of this presentation, just like I do. But here's the bur oak and a little bit of trivia about it. What makes this tree really well suited for climate change is the fact that it's drought resistant. So it's got this thing called the taproot, which is directly below the trunk, right? And the taproot goes deep into the ground, into the earth, to soak up food, nutrients, and water. And so if it's got a deep root that goes really far into the ground, it's able to pick up water that other trees can't get, which makes it perfect for drought when it hasn't rained in a while, because there's still water stored in the ground that this tree can access. So that's a really cool feature that not all trees have. So it's really nice that bur oak can do that. This is just a fun fact about trees, but I didn't know this until I went to college. So you guys are learning this really early, but trees kind of have genders, not in the same way that people do necessarily, but they do have male and female parts, right? And so the bur oak is really interesting because it has them both on the same tree. So you can see in the top, there's something called pistillate flowers, and that's the male part. And then it's got this thing called staminate flowers in the catkins, that's the lower part, and that's the female part. And so it's just cool that this tree has both those parts on it. So theoretically, it doesn't even need other trees around to reproduce. So it's nifty that they have it that way. Some trees do not. Some trees have like male trees and female trees. So it's just something that kind of surprised me when I learned that in college. So another thing about bur oaks is they're named after the burrs from the chestnut trees. You probably aren't super familiar with chestnut trees, even though they used to be one of the most popular trees in all of North America. Chestnut trees died out after this disease hit them. And so we don't have them around anymore, but they used to be, and that's why bur oak got this name. But bur oak has that beautiful fringed acorn cap that looks very similar to the chestnuts in the top photo of the chestnut tree. So that's where the name came from. And then one of the awesome things about bur oak is it produces so many acorns, and so it's an incredible food source for wildlife. Check out this photo below of just all the incredible species that rely on the bur oak for food. So if you love any of these species, you should love the bur oak because it's just such a good tree for all of them. So that's bur oak. There's plenty more to talk about, so I'm going to keep on going, but this is another really nifty tree in our waterway. You can see here in the leaves, so this is the top part of the leaf in the top left photo, and then directly next to it is the underside of the leaf, and you can see how it's two totally different colors, right? So you've got kind of like this darker green, and then you've got like a pale, almost silvery green, which, hint, hint, that's kind of what gives the tree its name. In the bottom left photo, we've got this thing called samaras. That's the seed packets, which I'll talk a little more about, but that's how the tree reproduces. In the fall, it turns this really beautiful red, but I think they also turn yellow. I might have to fact check myself on that, but they do turn very beautiful in the fall. And then in the far right photo, it just shows that they love these river type ecosystems. They love being near water where they can get their feet wet, right? Their roots wet. So what is this? Well, it's a silver maple named after the silvery underside of the leaf. There's awesome trivia about it, so let's get into that. But like I said earlier, the fruits are called samara, and they act like seed helicopters. They kind of act like that. The wind hits, and they helicopter down to the ground and plant a baby tree wherever they fall, which is pretty cool. They're one of the first trees to green up after winter. So right now, a lot of our trees are still brown. Silver maples are going to be some of the first ones that turn green. So I kind of love them for that. One of my favorite trees for that reason, actually. So keep an eye out for any trees turning green, because those might be silver maple. You can also tap it for maple syrup. So if you love maple syrup as much as I love maple syrup, you will love these trees for that. They're not as good as sugar maples for this particular purpose, but you can do it. You can also use red maples, box elders, and birch trees for syrup. So it's just cool that when we think of syrup, we think of sugar maples, but you can actually get syrup from multiple different types of trees. So, and this is one. Then, as I mentioned, this is a very common tree. Usually if you see one, there's a bunch more around it, and especially if you're near waterways. So if you're ever outside on a kayak or a canoe or by a river, look up and you might be able to see some silver maples near you. So the branches are also really smelly when broken. So, and that's not a common thing with maples. So that's a good way to tell if this is a silver maple. Just give it a sniff. And then they can grow 3 to 7 feet per year, which I think is pretty impressive because I'm only 5 foot. So this tree is growing my size every year, and that's pretty tall in my book at least. So that's the silver maple. Let's talk about this tree next. So this tree, there's not as many good photos, but that's because this tree is mainly one you would want to feel, right? So this tree is best identified by its bark right here, and the photo doesn't do the best justice, but this bark is very soft to the touch, right? You could press on it and it would kind of bounce back, and it has some give to it, right? It's got these pretty leaves. They kind of look like spades almost. Then it's got these berries, which makes sense because this tree is called the hackberry. It's after the berries it has, right? So this slide looks a little different because it's on a cork board. I did that on purpose because the bark feels like cork, right? So if you were to press on those ridges right there, it would feel like you're pressing on a cork board. That's how soft it is, right? So that's one of the best indicators for this tree. There's no other tree in this area that has bark that feels quite like that. So that's a really easy way to tell if it's a hackberry. This tree also thrives in what we call riparian habitat, which means near water. So you might find this near those silver maple trees we were just talking about. And then it's got these edible berries for both wildlife and humans. So, fox squirrels, turkeys, sharp-tailed grouse, and robins would all eat these berries, but we could too, which is just really cool that there's food on the landscape for us that we could eat. But again, do not eat food if you don't know for sure exactly what it is. So I wouldn't recommend going into the forest and just eating berries. But if you knew it was a hackberry tree, theoretically you could. So with adult supervision. But yes, and then we've got another really nifty tree. This one, you can see the leaves are way bigger than a lot of the trees I've already shown you. These are just like big leaves, like probably at least the size of my hand, probably bigger. They kind of look like hearts, a little lopsided, but still hearts, which is kind of romantic, I suppose. And it's got these cute little flowers, which you can see in the top middle side. And then very, like, I don't want to call it boring bark, but the bark is not very descriptive. So I wouldn't really identify the tree using that. I would really rely on those leaves and those flowers. But in the winter, the bark's all you have. So that's what it looks like. But perhaps you've guessed by now, maybe not. This is a less common tree, but this is basswood. Super cool tree. There's a lot of fun facts about it, so let's dip into that, but it's a tree of many names. One of the names is American linden, which is a really popular name for it, so you might know it by that name instead of basswood. It's also known as the bee tree, which I've never heard of it referred to this. I've never heard someone actually call it this out loud, but I think I'm going to start. So why does it get that name? Why is it called the bee tree? Well, it produces honey with a distinctive taste, light, mild, and slightly buttery. The tree itself does not produce honey, of course, but the bees love those flowers, especially because the flowers pop up in late summer when most of the flowers most of the wildflowers and other flowering plants have already bloomed. So this provides a really great food source when the bees don't really have all that much food left. So people love the tree for providing that food for bees, which gives us really good tasting honey. So I do love that. Like I said earlier, these trees have kind of heart-shaped leaves, and it's got this thing called the serrated margin. So it's that zigzag on the edge of the leaf. That's called serrated. This tree is also really fast growing, like the silver maple, and it can grow to be up to 80 feet tall, which I should have done the math earlier, but I think that's about 15 of me standing tall. So that's pretty tall. That's a lot of people on top of one another just to make one tree, right? So, and then this tree has really soft, light wood that's great for hand carving. So if you've ever carved anything, basswood would be a good tree to do that out of. You can use it to make baskets, rope, and fishing net, which is very nifty because when I think of, say, fishing net, I think of plastic, right? And that kind of plays into the keynote talk we had today, right? Is I think of all these items that are made of plastic, rope, fishing nets, etc. But at one point, they were all made out of wood or could be made out of wood. And basswood is one of those trees where theoretically you could do that. You could still make fishing net out of its bark, which is just so cool. Hopefully you find that cool too. Here's another climate winner, trees that we're going to be seeing more often on our landscape. So you can tell this one, if you know this tree, you probably are able to identify it based off of the two left photos. So those kind of like lemon looking things on the tree, those are kind of the fruits. So I've got the top photo showing what it looks like when it's on the tree. And then the bottom photo is what it looks like if it's opened. You can see there's a walnut in there. And then you can also see in the other photos the bark and then the leaves. The leaves are really interesting on this one because it's got a bunch of leaves coming off of the twig, whereas like the other ones, you just had a single leaf. This one has a bunch of leaves, right? And that is only characteristic to ashes and sumac trees out here, as well as the black walnut. So that's what we're looking at right now, the black walnut tree, which makes sense because it's got walnuts. So here's some trivia about that. Reasons why we should love it. So this tree, you don't often see the poison sign next to trees, but this one I wanted to add, right? So black walnut isn't poisonous in itself. It's not going to hurt us, but it is interesting because it creates a chemical that will kill other plants around it. So this tree is very aggressive in that sense. And when I think of trees, I usually think of, like hugging them or peaceful or calm, but trees are not necessarily like that, right? Some of them have defenses and can fight and stand up for themselves, even if we can't see that. So the black walnut is one of these where it produces these chemicals that will kill plants that are growing near it. Especially susceptible trees are pine trees and, say, tomatoes. So if I had a garden, I would not want to put it near a black walnut tree because the poison will kill my plants, right? So I just think that's super cool that trees can do that. So oddly enough, like I said, it may be poisonous to plants, but it's not poisonous to us, and it actually creates edible walnuts. So if you like walnuts from like your trail mix, you could actually find that in your backyard using these black walnut trees. So this is what walnuts look like on the inside. You would have to take one of those green fruit-looking things, break it open, and then you'd have to break the walnut open. So it takes a lot of work, but theoretically you could eat the walnuts from this tree. So you could also dye things with it. So these fruit husks have these very strong dyeing properties. And you can see in this photo all the different yarns that they were able to make using this tree, all the different colors, right? So, and I know I've grabbed these fruits before with, say, a white shirt on and had stains going up my shirt because of it. So yeah, don't wear white if you're near this tree, or at least don't try to open the fruits. So. And then another way to tell is this one has a very pungent or spicy smell. So if you were to see these husks and break one open, you would be able to smell it really, really strongly. So, and that's characteristic only to the black walnut in this region. So that's another really easy way to tell if it's that tree or a different tree. So really cool tree. Love it. Then we're on to, I think, our last tree for climate champions. And then we'll go into some that aren't going to do as well with climate change. But this is kind of similar to the bur oak. You can tell by the leaves that they're kind of in the same family, right? So you've got these smooth leaves with these deep, they're called sinuses. So these deep kind of like openings in between the leaf, right? And then it's got these acorns, which is very common to the oak family, which makes sense because this tree is a white oak. Very cool tree. So here's some more facts about that. White oaks. So oaks are interesting because they kind of fall into two families. You've got the white oak family and the red oak family. And then you've got the white oak tree, which is different from the family. It's its own specific species. So, but white oaks are known for having, like, I don't want to say leaves shaped like this, right? But leaves that have these smooth edges on the lobes. That's what they're called. So they have smooth edges. Whereas red oaks will also have these lobes, right? The kind of hilly looking things, but they'll have points on the edges. And that's a red oak compared to a white oak. So you can always tell white oak by that. Reasons to love this tree. I don't know if you like bats, but I like bats. So this tree is really cool because it's got this shaggy bark and it gets shaggy. Well, it gets shaggy up near the top of the tree, but it's kind of smooth near the bottom. And bats are really, really small. They can get really tight. And so what they like to do is they like to roost inside the bark, inside the shaggy parts of the bark. And this is just pretty nifty because most other trees have to be dead to provide roosting habitat for bats, but not white oaks. White oaks can be alive and provide that habitat, which is really great because it means bats can come back year after year after year after year and have wonderful habitat. So this is a really cool concept too. So white oaks engage in this thing called mast years. Bur oaks do this as well. Most acorn producing species do participate in this, but a mast year, I'll try to explain it like this, right? But on a normal year, an oak produces, say, 4 acorns. You can see the acorns at the bottom, right? So they do that for year 1, 2, 3, 4. For 4 years, they produce, say, 4 acorns. They produce way more than that, but for this example, we're talking about 4. On a mast year, which is maybe like year 5 or year 7, right? The tree will produce a lot more acorns, like 2 times, 3 times, 4 times more acorns than it usually does. And it's just really interesting because the trees are able to kind of talk to each other. They can communicate. So in this year, the entire forest will produce like 7 times or 5 times, however many times more acorns than it usually does. So we get this like huge number of acorns for 1 year. And then the 4 or 5 years afterwards, we get only a tiny number of acorns, right? And that's just really cool adaptation these oak trees have. They do this because if they produce just a total surplus of food, think about like Thanksgiving, right? You're not able to actually eat everything, right? So the squirrels and the mice and whatnot can't eat all the acorns that are available. They just have so many acorns, they get full, they can't eat them all. And so that means that more acorns have a chance to survive. And so, yeah, so they do that. So then they have a bunch of survival for 1 year. And then in future years, they produce less to bring those animal populations back down, right? So yeah, really cool that the trees can communicate and coordinate to help them all survive. So, and then one other thing is deer love white oaks. It's like one of their favorite foods. So if you like deer, you should like the white oak. They love to nibble on the new seedlings. So if these acorns survive, the deer will come the following year and try to nibble on all the ones they can find, and hopefully some acorn seedlings survive and live on to participate in a mass year themselves. But yeah, deer love this tree. And now that we've talked about a bunch of species that are going to do really, really well, I do want to talk about a couple that are not going to do well. So that way, when you see them on the landscape now, you can give them a hug, or just, keep in mind that things are going to change, and the forest we have today isn't the same forest we're going to have in 40 years, So what species are at risk? Well, this species, for one. The photo could be a little better, I'll admit, but this tree, similar to the black walnut tree, has a bunch of leaves that come off of one kind of stem. So they're called leaflets when they're like that. It's called pinnate too, but I'm not going to go too far into the jargon. And it produces these really pretty little seeds that kind of float around in the wind. And that's kind of how that works. So this is an ash tree. There's a couple different types of ash trees, but they're all at risk, so I'm just including them all together. But an ash tree includes black ash, green ash, white ash, blue ash, prickly ash, although those ones aren't really true ash trees, but there's a bunch of different trees that fall in the ash family, and they're all at risk. And that's really sad because we have a bunch of ash trees in our region. So this is going to be a really big change to our forests that we haven't quite seen yet. But why is it at risk, right? So let's talk about that. So we've got this really pretty tree. It turns a really pretty color in the fall, so I do love it for that. And there's this bug, emerald ash borer, which creates these they're called galleries. It creates these S shapes in the bark that kind of, it kills the tree because it stops it from getting food and water up throughout the tree. And so why is this related to climate change? Well, emerald ash borer is an invasive species. It came somewhere from Eurasia, and essentially it doesn't do very well in the cold. It has a really, really hard time surviving our Minnesota, Wisconsin winters. But as climate change gets progressively more severe and our winters warm up more and more, it's going to make it easier for this bug to survive. And that's problematic for our ashes, because the more bugs there are, the more ashes get infected, and the more ash trees die as a result, which is a bummer. There's only a 1% survival rate for infested trees. So if you see an ash tree, something that looks like this, maybe give it a hug, because it probably won't stick around for another 40 years, not in this region, unless we find new treatments or ways to protect our forests. And I do want to say, not all ash trees are going to die from this, right? There's the 1% that are surviving. And then we also do have some treatments. So if you have an ash tree in your yard, your family could give that tree shots almost that would protect it from this bug. So yeah, not going to do super well, but that's okay, because some species will, right? Diversity is key, as we've established. And then this is the very last tree. So thank you all for sticking with me. I don't know if any of you recognize the tree just right off the bat, but this tree is noticeable because of its kind of asymmetrical leaves, right? So they're not quite perfectly foldable on top of each other, right? And they've got these jagged edges, almost like a shark fin. It's got this deep furrowed bark and these really pretty seed packets that are just so papery and delicate, and these pretty flowers. And so if you are looking at this and saying, that looks like an elm tree, you would be right. So let's talk about elms. So this one's at risk for a different reason, also due to bugs partially, but a different reason. But elm trees have been kind of at risk for a while now. They used to be a super, super common tree. You would know these trees at a really young age. They were that common. They were just everywhere, right? And so in the 1960s, Dutch elm disease was introduced. Not Dutch people. Anyways, Dutch elm disease was introduced. It came from Europe, but essentially this disease came from Europe, and we did not have any protection against it in North America. And so this disease came and it killed a lot of our elm trees. Not all of them, but a lot of them. So it's not a very common tree anymore. This disease, Dutch elm disease, causes severe wilting, which is really hard for the trees to survive. So in this photo, you can see the kind of yellow and brown in the tree. And that essentially that tree is losing those leaves. Those leaves are going to die off. And as the disease progresses, this tree is going to lose more and more and more leaves until it can no longer survive. Because leaves are really, really important for giving the tree energy and food and whatnot. So without them, the tree will die. So how is this disease caused? Well, it's kind of a partnership between a couple of things. So we've got the elm bark beetle, which is the bug that created those actually kind of pretty, they're called galleries, but those pretty markings on the tree, that's actually caused by the beetle. And the beetle has this fungus on it sometimes. And so when the beetle burrows into the tree, it brings the fungus along with it. And that fungus is what carries Dutch elm disease. So it's kind of like a beetle and a mushroom together take down a tree, which is kind of crazy when you think about it because they're so small. And these trees are so big, but they can have such a crazy impact, right? So these trees used to be they used to live to over 200 years old, which we've established some of these trees grow really, really big. So if you can imagine a 200-year-old tree, that must just be so big, like tall and wide and just a really impressive tree. But now they only live to about 30. So almost every elm tree that's grown in my lifetime around here is probably dead or on its way to dying, which is really interesting. And someday it might go back to being over 200 years old. We'll see. But this story is not really that sad, though, because there are disease-resistant varieties. So elm trees that are resistant to this disease. So that's really exciting because we don't have that for ash trees quite yet. So it's just really cool that for elms, we'll have them into the future. We'll just have less of them. But someday they might not have to deal with Dutch elm disease because they're resistant. So we love that. And then also treatments exist. So you could give these trees shots almost. If you think of like the shots you get at the doctor, you could give trees shots almost, and that would protect them from this fungus. So yeah, these trees aren't going to do great with climate change, but it doesn't mean they're going to go away. We're just going to see a lot less of them. And that's really important for, say, the wildlife that relies on them or for the people that love them. So yeah, those are our trees. So I'm going to ask you again, what's your favorite tree? Did your opinion change after this presentation? Perhaps it did. I don't know. I still have a really hard time choosing, but you don't have to put it in the chat. I would love to see it. But it would be awesome if you just thought about like, what is my favorite tree? Because I think that's a really important thing for people to love the trees around them. So with that, I'm all done. Please ask any questions you'd like. I'm going to be sticking around until this is over for the next 5 or so minutes. So yeah, ask me any questions. Happy to talk about trees anytime. Thank you all for being here. So I'll stop sharing. There we go. Oh, Tanner, I can't hear you.
Thank you, Alexis. That was an awesome presentation on the trees in the Riverway and their resiliency to climate change. Got Katrina shouting out Bur Oak is her favorite. Not as cool as a white oak, but it's close. A question I have as we wait for a few questions to pop in the chat here. How do scientists or researchers know for sure which trees will do better as the climate shifts? Are they doing studies or are they guessing, or how do they kind of come about that idea?
Yeah, that's a really good question. So there's a lot of ways to figure it out. It's quite complex, but the main ways they're doing it is they're looking at the tree's range, right? So they're trying to see, where does the tree grow right now? Can it live further north than us? Does it live further south than us? Whatnot. They're trying to see if the trees already live in warmer climates. And if so, then that means they'll probably live in our warmer climates as well. So yeah, so they're especially looking at trees that live a little further south than us. And then they're also looking at diseases that the tree is susceptible to. So they're trying to see if those are going to become more common. So like, even though ash trees could survive here, they're not going to survive very well if emerald ash borer is here. So they're also looking at pests and whatnot that might move into the region and impact our trees. But and then they're also just planting a bunch of trees and seeing which ones survive. So there's always those awesome research studies as well. But and a lot more that goes into that. But that's the gist of it. So
awesome.
Yeah.
We have another question. How did you get into the climate field? And maybe I'll add to that, if since we have students listening, are there some classes or materials you would point them towards to further their climate learning?
This question always makes me laugh because I feel like I'm supposed to have a very life-changing moment or significant moment in my life that caused this, and I think it really came down to the movie E.T. So maybe not E.T. Oh my gosh, WALL-E. My bad. The movie WALL-E, which I don't know if everyone here has seen that, but that's a Disney movie or Pixar movie that's incredibly cute, and it's about this little robot that's freaking out about all the trash on Earth and is trying to find the last plant, right? And I think I saw that and was like, oh, I saw like a bit of our future in that movie, and was like, I don't want to live in a world full of trash. I want to live in a world full of these beautiful plants and whatnot. And I don't know, it just had this big impact on me. And so after that, I just gained a bit more of a appreciation for nature and started to really get interested in the plants and the trees around us, and learned a lot more about climate change and the fact that we can still take action on it. And from there, I was like, okay, I'm going to go to school and I'm going to learn about climate change and the environment and see what I can do to make a change. So it kind of started that way. And then I took a bunch of classes that got me here. So my school offered environmental science, and that was a really awesome class for that. Took biology. I would have joined the environmental club if we had an environmental club. So I recommend checking those out. Here, if you end up going just a really fancy school that has something about botany or has a garden, I'd join a gardening club maybe, but anything that has to do with plants is a good way to get involved, I think. So.
I think you brought up something that might be a good point to end on. But with climate change, it's not black and white. It was like, this is our, like what our final environmental world that we live in will look like. There's multiple projections and paths we can take. Can you talk a little bit about that, and how that's a little bit inspiring, and there's actions we can do, and it's not all evil and dark?
Yeah, exactly. So I feel like with climate change, there's so much anxiety and whatnot going on about it, which makes sense. I feel anxious about it. I'm not going to pretend I don't in some ways, but what gives me hope is the fact that we are not, our world is not set in stone, right? There are actions we can take today that will reduce the impacts of climate change. So maybe we won't lose those species like ash and elms from our landscape, right? There's things we can do today that will protect us into the future. And those things are things like renewable energy. There's a presentation on that. We could start using that. We could start planting species that are going to do well with climate change. We could start planting more plants that are going to absorb carbon, enacting policies, voting in people in politics that care about this stuff. So writing letters to your governors and whatnot, which I remember doing when I was in middle school. So you could do that too. There's just so many different small things we could all do as individuals that would help us get to a world that's more similar to what it is today. It would help us get to a world that we want to be in instead of one we're scared to be in. So there's a lot of hope.
Good. That makes me happy to hear that from our climate resiliency specialist. So
Yes.
Great. If there are no other questions, I will wrap up here. I encourage everyone listening to attend our next set of sessions and our final sessions happening at 1:30 p.m. Alexis, thank you for sharing your knowledge with all the students today. We really appreciate it.
Thanks, Tanner. Thanks, everyone, for being here. Bye.